Today we're talking about Chapter 1, Section 4, Quadratic Equations. Right. So this is pretty much the meat and potatoes of college algebra here, quadratic equations. Honestly, a lot of the math courses that you'll be coming across, really. Mainly because they're really easy to solve, and there's multiple ways to go about them. All right, so let's just get all this. Okay, that's all we'll fit here. Alrighty, so starting from the top. In section 1.1, we talked about linear equations. Again, these are equations that create a line, right? Ax plus b is equal to c, where a is not equal to 0. These equations are also known as first order polynomials. That order basically means the degree of my exponent. And you can see here, the degree of my exponent is, it's 1, right? X to the first power. All right, so it's first order, first degree. In this section, we learn how to solve second order polynomial equations. Again, second order would be second degree polynomials. Second order polynomials are called quadratic equations. Now, real quickly, why are they called quadratic equations if they are if their polynomials raised to the second power, right? When you hear quad, you usually think of 4, correct? That's true, all right? Well, the reason why, and this is what I've heard, is because if you were to, take some sort of square, okay, that has side s, side x, all right, that side is, x length long, then the area of that four-sided square would be x squared. Okay, so that's what I was told. That's what I've always just thought. I guess I never really put too much attention to it, but it makes sense, right? Because otherwise, quad means 4, quadratic equation. That was only a secondary polynomial, but here we are. Okay. Anyways, the quadratic equation in one variable is an equation that can be written in the form ax squared plus bx plus c is equal to 0, where a cannot be equal to 0. Because again, if a was equal to 0, we look here. Well, then we would just have us a linear equation, wouldn't we? Bx plus c. So that's why a cannot be equal to 0. Okay. Now, down here, some quadratic equations can be easily solved by factoring and by using only the important property, the zero product property. Okay. Now, zero product property is honestly probably the most important thing we're going to learn. In terms of solving polynomials, because what it does, it tells us that if we have some a times b and we can equate it to 0, then we know either a is equal to 0 or b is equal to 0. Okay, it is how we solve these quadratic equations. Okay, and of course you've done this before, so hopefully it's nothing new for you. But anyways, going down here, it says the zero property says that if two factors multiplied together equal to 0, then at least one of the factors must be 0. Makes sense, okay? And it also goes for, honestly, more than just those two. If we had a times b, all right, there we go, times c times d times e is equal to 0, then either a is equal to 0, b is equal to 0, c is equal to 0, d is equal to 0, or e is equal to 0. Okay, so it does imply that as well. All right, so let's do an example, and this is a great time to try to remember how in the world we do this, okay? Or we solve this particular problem. All right, now we need to solve this. To solve, let's use zero property. Okay, so generally, if you see something like this, you want to factor, okay? And so in order to factor, we need to get everything on one side. So let's go ahead and get everything on one side here. So we've got 6x squared minus 17x plus 12 is equal to 0. Okay, and again, we put it in descending order with respect to the variable x squared, and then x, and then the constant. Right? Now you might be looking at this and go, well, I don't know how to factor this, right? Like if this 6 wasn't here, it'd be a lot easier to factor. And you're right, I feel you. That's exactly how I am. If that 6 wasn't there, if a 6 wasn't there, it'd be a lot easier to factor. but it's there. Okay, so here's what we're going to do. We're going to do the zero product, I'm sorry, not zero product, the AC method. Okay, now this might be, it was, I think it was went over in the review sections. If not, pay attention. You're going to use this quite often the rest of this class, the rest of pre-calculus, and the rest of calculus when and if you get there. Okay, so the AC method, what we're going to do is we're going to look at the A value and the C value. Okay, again, the A is the number in front of the X, and the C is the constant. Okay, so we're going to call this the AC method. So what we're going to do is we're going to go over here, and we're going to say 6 times 12. Okay, well, 6 times 12 is 72. Let's fix that up. 72. Okay. Now, if this was like a -12 or a -6, I wouldn't care. I would just deal with the their positive components. Okay, and here's why. You'll see. So, anyways, as we go, all right. So I'm going to underline that, and then I'm going to write down my factors of 72. Okay, I'm going to start with the easy one. 1 times 72. Easy enough. All right. Next, we're going to do 2 times 36. 3 looks like goes into it, what, 24 times? 3 times 24. 24, yep. 4 goes into it also. 20 and 18 times. 5 doesn't. 6 does. 6 goes into it. 12 times. 7 doesn't. 8 does. 8 goes into it 9 times. And then 9 does. 9 goes into it 8 times. So we repeat, okay? So what I did was I wrote down my A and my C right up here. And then I multiplied them together again. AC method, A times C. And then once I did, I got 72. And then I wrote down my factors of 72. Okay? And then once I write down my factors of 72, what I'm going to do is I'm going to say, okay, so which one of these factors, when I add or subtract them together, will give me my middle one, my middle number there of -17. Okay? So which one would give me the -17? It looks like 8 and 9. Okay, so what we're going to do is we're going to say a -8 and a -9. Doesn't make sense. Okay, a -8 and a -9. Okay, so I mean it does make sense. So let's rewrite this. So we're going to rewrite this like, okay, let's put a star by it. The 8 and the 9. Okay, so I'm going to rewrite this. We're going to say 6x squared, and I put the little star by the 8 and the 9. So what I'm going to do is I'm going to say -8x -9x plus 12 is equal to 0. Okay, so now I've essentially rewrote the first problem. Okay, the difference between this problem and this problem is all I basically did was I took the -17 and made it into two numbers, which makes sense, right? -17x, well, that's the same thing. I mean, I can say -8x and -9x. They're the same thing, right? And just to really kind of drive the point home, I'm 34 years old now. Okay, so I'm 34 years old, right? But that's also the same thing as saying I'm 21 plus 13 years old. That's it, right? I mean, it means the same thing. So that is essentially what we did. Now what we're going to do is we're going to do something called factor by grouping. Okay, so what I'm going to do is I'm going to factor the left side of that dotted line. Okay, so the left side of that dotted line, what does that factor into? Well, it looks like I can factor a 2x out. And what remains? Well, that would be a 3x minus 4. What can I factor out of the right side? Well, I can factor out okay, here's the tricky part. I'm gonna do it this way, and of course you're gonna run into this problem multiple times, so now once you do it, you'll understand. But let's just factor out a positive 3. So I'm gonna factor out a positive, this one plus 3. And so if I factor out a positive 3, I'd have a negative 3x and then plus 4. Okay. Hopefully you see the issue here. Once I do the factor by grouping, the whole point behind this is to get this number in parentheses and this number in parentheses to be the exact same. And if you do it correctly, they will be the exact same. But notice how they aren't, right? One is a positive 3x, one is a negative 3x, one is a negative 4, one is a positive 4. So how can I fix that? Well, instead of factoring out a positive 3, what I'm going to do, I should erase all this as well. What I'm going to do is I'm going to factor out a negative 3, right? Because the only difference was the sign, so I'm going to factor out a negative 3. And therefore, I'll have a 3x, and then I'll have a minus 4. So now what's inside are the exact same, and then I can essentially factor those out. So what I mean by that, I can essentially factor those out. Let's assume that this equation was 2. Let's do this. Let's imagine that the 3x minus 4 are alphas. Okay, just big old alphas. So my equation is now going to be 2x alpha minus 3 alpha, right? So what does this mean I can do? Well, it means what I can do now is I can factor out an alpha, right? Alpha is in both of them, so I'm factoring out an alpha from both. So I'd have 2x minus 3, right? Because I factored an alpha out of both of these, right? Now, I chose alpha because I feel like y, I would have to really stretch it to be a y. But anyways, alpha being the variable, I would have to, I could factor the alpha out of both. And so that's essentially what we're looking at, okay? In both of these terms, if I were to get rid of this dotted line, you can see that both these terms, both the first term, both the first term and the second term have the 3x minus 4, so I can factor it out of both of those terms. So that's what I'm going to do. Let's put those dotted lines back. Okay, so we're going to factor a 3x minus 4 out of both those terms, and what remains would be a 2x minus 3, just like that. Okay, and we're going to have to go to the next page here. All right, so once I did that factoring, now I can do the zero product rule. Again, zero product rule being, a times b is equal to 0. I have that form. A times b is equal to 0. So what I'm going to do is I'm going to set each one of these equal to 0. And then I'm going to solve for x. So over here I've got x is equal to, I add 4 divided by 3, x equal to 4/3. Over here I've got, I add 3 divided by 2, I've got x is equal to 3/2. Okay, and that's how we solve, or that's how we factor those kind of problems. Okay, so again, just a quick recap. We did the AC method. We looked at the A value, the C value. We multiplied those together. We got 72. We took the factors of them, okay? Once we did that, we asked ourselves, okay, so which one of these factors, when I add or subtract them together, will give me negative 17? Okay, not negative 17x, or simply negative 17. Okay, and then we said 8 and 9, right? A negative 8 and negative 9 is equal to negative 17, makes sense. So then what I do is I rewrote the negative 17 as a negative 8 and a negative 9. And then I just put a nice little dotted line down the middle, and then I factored by grouping. And then once I get done with factor by grouping, I set each one equal to 0, and I solve for x. Let's see. I'll snip this. This might be important. I'll give it a quick little read real fast. Yeah, we'll just go over it. Okay, so consider the quadratic equation x squared minus 9 is equal to 0. The left-hand side is a difference of two squares. All right, so a difference of two squares is easily factorable into x plus 3x minus 3. I set each one of those to 0. I get x minus 3x plus 3. I don't know if it really drives that point home. So let's just go ahead and go for the example. It is good, but I feel like, again, as a student in this particular course, one that's not interested in math, where I'm sure many of you are at, you like examples better. Okay, so we're going to go to the square root property. Okay, now square root property is exactly like it sounds. Okay, what we're going to do is essentially isolate the x and then take the square root of both sides. So let's start with a. We're going to isolate the x, so we're going to go ahead and start this off as x squared is equal to 16, right? And then we'll take the square root of both. Oh no, that's a big deal. Okay, no, this doesn't say it over here. Okay. Okay. No, it says it up here, Sherman. Dummy. Okay. Sorry about that. I was confused as to why we're doing this without being told. Okay. So the square root property, the solution to the quadratic equation x squared minus c is equal to 0, or equivalently x squared is equal to c, right? I would add that to both sides, is x is equal to plus or minus the square root of c. All right. Now, plus or minus, the reason why is because whenever you take the square root of both sides, you're taking the positive and negative component of that x value. Okay. So again, what does that mean? Well, first things first. Now, a is a difference of squares, and I could solve it as a difference of squares. And I guess I will when I'm done with this part. But they're not always going to be difference of squares. So we're going to do it this way. So anyways, what I'm going to do is I'm going to do this, and then I'm going to take the square root of both sides. Okay, and when I take the square root of both sides, what happens is I have to take the positive and negative component of that. Okay, now why? Why do I have to do the positive and negative component of it? The reason why is because if you think about like number 9, okay, well, 3 squared is equal to 9, right? Well, so is negative 3 squared. Okay, so that's what I have to do the positive and negative component on there. But anyways, as we move on, the square root of x squared, that's easy, that's just x. Okay, and that's going to be equal to the plus or minus. All right, what is the square root of 16? Well, that is 4. Okay, it's that easy. Now again, I did say a is a difference of squares, so you can easily factor this. Okay, so let's do the difference of squares way. I know that x squared minus 16 is the same thing as saying x plus 4. No, let's make it equal to 0. Let's just be consistent here. Okay, a little arrow there. X plus 4, x minus 4 is equal to 0, and then we solve each one of those for 0. Okay, so x plus 4, I set that equal to 0. I get x minus 4. X minus 4, I set that equal to, I'm sorry, last sentence, forget that. When I set x plus 4 equal to 0, I get x is equal to negative 4. When I set x minus 4 equal to 0, then I get x equal to positive 4. So I get the same thing, x equal to plus or minus 4. Okay. All right, B. First thing I'm going to do, first thing you do for everything, if you're able to do it, is factor it. Okay, so I'm going to factor a 2 out. And what remains is x squared, x squared plus 36, and that's equal to 0. Okay. All right. So I mean, we can just do some of this in our head. If we divide both sides, by 2, all right. Well, I mean, that's essentially, it's just going to take that 2 away, isn't it? Okay. So it would turn the equation just simply into x squared plus 36 is equal to 0. All right. Well, I'm going to subtract 32 from both sides. So we're going to resume this down here. I'll have x squared is equal to a negative 36. I take the square root of both sides, so let's do that again. So minus 36. If I take the square root of both sides, like this, I would say the plus or minus of it, just like that. And then again, the square root of x squared, well, that's just going to be x. And then I've got the plus or minus is equal to plus or minus the square root of negative 36. And we know we take the I out, And then the square root of 36 is 6, so it would just be 6i. Okay. And let's go to C. New page. C. Right, so we've got x minus 1 quantity squared is equal to, and I'm just going to go ahead and do the whole thing where I'm taking the square root of both sides. Oops, let's not put that in. There we go. Take the square root of the left side. Okay, well, the left side's pretty easy. Again, the square root of something squared is just that radicand, so x minus 1, that's going to be equal to plus or minus the square root of 7. Okay, all right, well, the square root of 7 isn't a nice number, right? So we can just leave that alone, but in order to solve for x, I have to isolate it, so let's isolate that x. So I've got x is equal to 1 plus or minus the square root of 7. All right, and that is that. Did I ever? There we go. Okay, and that is solving thanks to this square root method. Okay. All right, now we get to the part where I know you're gonna hate. I'm sorry, we just have to do it though. That is let's see. Let's go ahead and snip this on there as well. Oops. New page. All right. So consider the following perfect square trinomial. You know what? I don't like that. We're gonna not touch that. We're gonna jump straight into completing the square. Okay. So the first exercise in completing the square, what we're trying to do here is we're trying to figure out what we're gonna add to the end of these equations to make them a perfect square binomial. Okay, a perfect square binomial is, okay, something like x minus 3 quantity squared. Okay, it is a perfect square because I can square it binomial. And so, for instance, let's actually do it this way. So okay, so we'd say x squared minus 6x plus 9. The x squared minus 6x plus 9 is a perfect square binomial, perfect square trinomial, I guess, because I can factor this into x minus 3 quantity squared. Okay, so what I'm asking here is, what do I add to each one of these to turn it into one of these so I can factor it into one of those? Okay, so I use very, very nice words there as in these and those, right? That didn't really help anybody though. So let's actually, again, get onto an example and maybe to drive the point home. Okay, so what I'm going to say is I'm going to say x squared minus 12x, okay? And then plus what? And I'm going to put a question mark instead of a variable there, okay? Plus what will make this a perfect square, okay? Now this is another thing that you need to write down or put a star by, okay? And I have mentioned in the past that you don't have to necessarily take notes, but put a star by it if you don't, okay? There's a 4-step process here, very, very easy, and I'm going to color coordinate this to show you how simple it is, okay? So first of all, I'm going to write down all 4 steps here. So step 1, step 2. Okay, the 0th step, I guess this isn't necessarily a step, and that's why I call it the 0th step, but I'll quit saying them out loud as to not confuse you, okay? So this is what it looks like. And the reason why is because I'm going to be filling in those blanks, okay? So here's what we're going to do. We're going to, let's actually, for the sake of clarity, let's do yellow. Okay, yeah, we'll do minus 12x. Okay, and then we'd say plus, and then we'll put a question mark here. Okay. All right, so here we go. So what I'm going to do is I'm going to take that negative 12, just the negative 12, and I'm going to put this up here in step 1. Okay. And then I'm just going to do the arithmetic. Okay, well, negative 12 divided by 2. Okay, well, negative 12 divided by 2, that is a negative 6. And then the negative 6 quantity squared, well, that's going to be 36. Okay, so pay attention to how I color coordinated that. Okay, well, that plus 36, okay, and it's always going to be positive, always, because I'm squaring whatever's in here. And a positive times a positive is positive, and negative times a negative is positive. So it's always going to be a positive number. Okay, so that 36 is what I'll put here at the end. So plus 36. Okay, now it is a perfect square trinomial because this factors into x, and then again, pay attention to the color coordination here, minus 6 quantity squared. Okay, now here's the thing. You could, and there's nothing wrong with it, you would take this particular trinomial and you would factor it. Okay, but when you factor it, you'll get to this. Again, the x minus 6 quantity squared, well, that minus 6 comes from over here. So it makes it nice, kind of neat, and easy to follow. Okay, so let's try b. Okay, that's going to be x squared plus 5x, and that's going to be plus, and it's the same thing as before, plus something. Okay, so let's go ahead and erase all these numbers right here. Oh yeah, I was gonna do that color coordination just right. So this is a plus 5x. Okay, let's go back. I got the sniffles a little bit, I'm sorry. Like this. Alrighty, so what number goes in the in step 1? Well, that would be the 5. 5, okay. Well, 5 divided by 2. Well, 5 divided by 2 is just 5 divided by 2. Okay, so there's nothing more you can do there. All right, and then 5 halves squared. Well, I would square the numerator, so it would be 25. And I would square the denominator, so that would be 4. Okay, excuse me. So if I followed along like I did with A, I can erase this question mark. Oops, a little big. I can erase this question mark. And this would be plus 25 over 4. All right, and that would mean over here, that would be x. And then again, it would be plus 5 halves quantity squared. Now again, excuse me, sorry. Again, if you were to look at this and I say, hey, factor this, all right, I mean, you probably could, but it might take you a few seconds, right? Which is why I color coordinate step 2 over there, and pretty much tells you that, well, okay, this is the factored form, and you get this 5 half from step 2. That's it, easy peasy. Okay, so let's do C. Same way. All right, so C has a nice fraction because we hate fractions. Okay, again, we're just going to put that plus question mark, same as before. Just go in here and erase stuff. All right, here we go. So what is my b value there? Okay, well that is a negative 3 halves, so negative 3 halves. Again, when I write small in here, it messes up a little bit. All right. Well, negative 3 halves. All right, negative 3 halves divided by 2. Well, that is a negative 3/4. Okay, well, let's do this negative 3/4. Okay, so some of you might be thinking, well, how do you do it so fast? And some of you might be thinking, well, because he teaches this for a living. But anyways, here's how we do that, okay? In case you forgot, negative 3 halves divided by 2. All right, so negative 3 halves divided by 2. Right? Now I can do this in my head, and I know that I basically just transplant that 2 to down here, and it becomes negative 3/4. Okay, but if I wanted to show you that arithmetic wise, all right. Now again, if you see this and you're just like, oh, that looks dumb, I don't know how to do that. Don't worry, neither do calculus students that haven't done this in a while. Okay, but instead, if I were to write this as negative 3/2 divided by 2, now does it come back to you? Now do you remember? All right, because now I know that I can rewrite this as negative 3/2 times 1/2. Remember? I I go from here to here by multiplying by the reciprocal. Remember? And so I multiply by the reciprocal, and that's how I get negative 3/4. So if you need to, rewrite it like this, and it'll come back to you. Excuse me. So anyways, that's that. And then what is negative 3/4 quantity squared? Well, that would become 9 over 16. And that's what I'll put over here, 9/16. And then again, that's equal to, and then I would say x, and then what's over there in that. Ooh, I meant to make that yellow. Let's make that yellow real quick to be consistent. What's negative 3/4? Okay, so minus 3/4 quantity squared. Okay, so what was the point of learning how to complete the square? Well, very bad news, because we're going to have to use it. Okay, so let's move along. The steps for doing the completing the square. New page. Now, all of those particular problems, we essentially skipped step 1 because a in all of them was already 1. Okay, so notice how a in all of these is a 1 right here. 1, 1, 1. Okay, if it is not a 1, then I must divide the entire problem by whatever a is. The rest of the steps I don't care about because, again, I did it my method, and I suggest you do it my method as well. Okay, so let's do it like this. Okay, so again, I'm going to go ahead and write my steps. My zeroth step is basically my my formula, right? B over 2 quantity squared. My first step, I'm going to plug in my b value. My second step, I'm going to divide by 2. And then my third step, I'm going to do the squaring. So let's go ahead and rewrite this. Honestly, I guess it's not terrible because we didn't do step 2 either because we didn't actually solve. Okay, but 1 and 2 we're gonna cover. But before you complete the square, you must make sure that you have a 1 as an x. Okay, or as an x. I'm sorry, 1 in front of the x squared. So let's rewrite this, and let's show what I'm trying to say. Okay, all right. So I need to have a 1 right here. In order to get it into a 1, what I'm going to have to do is I'm going to have to divide this entire problem by 3. Excuse me. All right, so by dividing the entire problem by 3, well, 3 divided by 3, well, that's just 1. Perfect. So now I can say this is x squared. All right, a negative 18 divided by 3, it's going to be a negative 6x. And then 19 over 3, it just has to be difficult, doesn't it? So 19 over 3, and then 0 divided by 3, that's just 0. Okay, so we got that. One moment. All right. Once I did that, I need to put all my constants on the right side. And realistically, I'm only going to have one constant, right? That constant is going to be this. So I'm going to take that and put it on the other side. So this is going to turn into x squared minus 6x. So this again, minus 6x. And it's going to be equal to a negative 19 over 3. Now I can begin my completing the square process. Okay. Alrighty, so here's what I can do. I can let's just go ahead and put the -6 up there. I didn't change the color of it to blue, but we know where we're getting it from, right? -6 goes up here. But we will change these colors. So -6 divided by 2, it's a -3. A -3 quantity squared is a 9. Okay, so what I'm going to do is I'm going to add 9 to this left side to put it in a form I can factor. Right? But obviously, if I add it to the left side, I must also add it to the right side, right? So let's do that. I will have x squared minus 6x, and then as a plus 9. That's going to be equal to a -19 over 3 plus 9. Okay. Well, the whole point of doing this was so I can get the left side into a square. Okay. So what is the factored form of the left side? Again, you probably can do this in your head, but just in case you can't, remember it's over here in step 2. Okay, so this is going to turn into x minus 3 quantity squared is equal to. Alrighty, now I got to do some math here. I have a denominator of 3 on the right side, so let's just do this out right here. The denominator of 3 on the right side, it's a plus 9. So how do I rewrite 9 with a denominator of a 3? 9 to 27, so it would be 27 over 3, right? 27 over 3 is the same thing as 9, right? But anyway, it's -19 and then positive 27. It gives me an 8. So this would be equal to 8 over 3. And then let's resume up here. All right. Now, again, the whole reason why we did that, the entire reason why we did that is for this point right here. Okay. So let's go back to example 2. Example 2, and see, nice, it has its own page. Okay. We are essentially wanting it to look something like this. The left side being, you know, some binomial squared equal to some constant, right? Once we got to this point, it was really easy to solve, wasn't it? Once we got to this point, what we did, we took the square root of both sides, and then, you know, we added 1 to both sides, and we were done. That's it. Okay. Well, we have to do completing the square because, and I guess I could have started off like this. If I were to ask you to solve this particular problem, the only 2 tools in your toolkit right now are factoring and the square root method. Okay, and looking at this, well, you can't factor it. All right, you just, I mean, I don't, no, you can't factor this. No, I mean you can, but you're gonna have to be like an absolute mathematical savant to do it. Okay, so that's all we have to do, the completing the square process, right? This point right here where this arrow is pointing at. This is the whole big deal. Okay, so let's do it like we did on the previous page. So we're going to do the square root of the left side, which was x minus 3 quantity squared. And that's equal to plus or minus the square root of 8/3. Oops, let's put that in white. 8/3. Okay, so again, it just basically looks like example C of example 2. All right. Well, the left side, that's easy, right? That just becomes the square root of anything squared is just that anything. So that's x minus 3. And then the right side is, you know, plus or minus the square root of 8/3. And 8/3 can actually, we can actually do something with that. But for right now, we'll just go on. Okay. And then, well, I guess I can just go ahead and play with it. Okay, so let's do this. X minus 3 is equal to plus or minus, I can say the square root of 8 over the square root of 3. I can go ahead and add, let's do this on a new page. It's getting a little tight. Okay, so from here, alrighty. So I'm gonna go ahead and add 3 to both sides. So x is equal to 3 plus or minus, and I can split this radical up into the square root of 8 over the square root of 3. Okay, and then what I can do here is I know that square root of 8 has a perfect square inside of it, so I can say x plus or minus, it's 4 times 2, right? So Yeah, this is kind of stupid. Okay, I can say it's square root of 4. Let's do this. Square root of 4 times 2 over the square root of 3. Okay, times 2. All right, well, I know that the square root of 4 is 2, so I can pull a 2 out. Okay, so let's just fix that up a little bit. It's 2 on the square root of 2. And we all know we can't just have a radical in the denominator, right? I mean, we can, but we like to rationalize the denominator. So how do I rationalize this denominator? Well, what I need to do is I need to multiply the top and the bottom by the square root of 3 over the square root of 3. Okay, and again, I'm just focusing over here. All I'm doing is multiplying by 1. That's all I'm doing, right? I'm not changing the value, nothing. I'm just changing the way it looks. All right, so from here, we'll put an arrow down here. I now have x is equal to 3 plus or minus. All right, so that would be the 2. I'm looking at the numerator first. The 2 in front of the radical stays the same, so it's going to be 2. And then the square root of 2 times the square root of 3 is going to be the square root of 6. And then the denominator, the square root of 3 times the square root of 3, well, that's just that'll turn into the square root of 3 squared. So it would just be 3. Whew. Okay, so that's that. Lots of talking, and that's it. So I guess that this particular problem, the entire point of this is to get to the completing the square process stage right here. That's the whole point of completing the square. And then once you do that, you just solve for x. And of course, we had a nice problem where we had to do multiple things, like this over here, but we ended up getting to our solution. Okay. Now, if you hated that, I've got good news and kind of bad news. The good news being that you don't have to do that every time. Instead, we're going to go to the nice quadratic formula that we are used to, the quadratic formula that we love. Okay, so let's go, let's make sure. Okay. Let's do the whole page. Alright, this reads, example 5, we see how we can solve a quadratic equation by completing the square. In fact, the method of completing the square can be used to solve any quadratic equation. Well, that's pretty handy, right? I said that you can't factor these in your head, but we can use the quadratic equation. However, this method is often long and tedious. Amen, right? Is often long and tedious. If we solve the general quadratic equation, ax squared plus bx plus c is equal to 0, we're going to end up getting the quadratic formula. I say because I'm going to actually show you. Okay, so now we have 3 tools in our toolkit to solve quadratic equations. The first one is factoring. All right, easy peasy. The second one is completing the square. The good and bad news is, the good news is we don't have to do it that often. The bad news is we have to do it. Okay, but for quadratic equations, I don't touch them. 100% I don't. The reason why is because the quadratic formula is the catch-all. Okay, but whenever we do get to circles, we will have to complete the square. Okay, so don't purge this from your memory bank. We will be using them whenever we get to circles, but for now, for solving quadratic equations, the quadratic formula is it. Okay, and just my own personal rule of thumb is if I can't factor an equation in my head in 3 to 5 seconds, I jump straight to the quadratic formula because it is the catch-all. It'll do it every single time, 100% of the time. Okay, but real quick, let's just do something. And again, for those that are that do take notes here, don't take these notes. Okay. So again, when I was taking math courses, this course in college, I was behavioral science, and I would look at this and I would be like, now how in the world does somebody come up with something like this? Okay? Does somebody sit in a dark room, candle lit, and just put in square roots, squares, pluses, minus, negatives everywhere until they figured out the right formula to solve quadratic equations? One moment. All right. Well, no, that's not the case. Okay. And not only that, but something this important, shouldn't it be named something more than, or something better than quadratic formula? Shouldn't it be named after someone, right? Because you've done this for years. I know you have. And you're going to do them for more years. Okay. So you'd think something this important would have a name on it, right? Because somebody sat in a dark corner for a long, long time and figured it out. Well, that was what I thought. I never asked questions. Um, so let's figure it out. Okay, so let's start with the quadratic equation. Okay, and again, if you're taking notes, definitely don't write this down. Okay, this has nothing to do with anything. It's just I'm showing you. Alrighty, so I told you before the first thing we need to do whenever we complete the square is we need to make sure we have a 1 in front of the x squared. Okay, right now it's an a. We don't know what a is. A could be 1, but we're not going to take any chances. Okay, so what we're going to do is we're going to divide the entire problem by a. Okay, well a over a, well that's just going to be 1, so x squared plus, well b divided by a is b over a. And then c is going to be plus c over a. Okay. And then we're going to put the constant on the right side. So we're going to say x squared plus b over a to the x power is equal to a negative c over a. Okay. All right. Now let's do it. Let's go over here. We're going to have our nice handy dandy little formula. And then step 3 we squared. Okay. All right. Well, what is my b value here? Well, that is b over a. Okay. So we're going to put b over a over here. Okay, well b over a divided by 2, that's going to be b over 2a. And b over 2a squared is going to be b squared over 4a squared. Okay, so what I'm going to do is I'm just going to skip the intermediary step, right? Instead of adding this to the left side, I'm just going to go ahead and write it in factored form. So I'm going to say the left side is x plus b over 2a quantity squared. That's going to be equal to negative c over a plus b squared over 4a squared. Okay. Alrighty, so now what I need to do, I need to combine like terms over here on the right side. Alright, so in order to combine like terms on the right side, let's actually go ahead and rewrite this in a way where I put this in front over here. Okay, so I'm just going to rewrite that and put that in front over there because it'll look easier on the eyeballs whenever I get to the nice big finish. So we said it was b squared over 4a squared, and then it's minus c over a. So all I did was swap them, right? I moved positions. Okay, so this one right here, I want to get a common denominator. Okay, so I have an a for a denominator and a 4a squared. So what I need to do is I need to multiply this fraction by a 4a in the denominator. If I do that in the denominator, I need to do that in my numerator, 4a. Okay. So let's do this, x plus b over 2a quantity squared. And it's going to be equal to b squared over 4a squared. And then we're going to have a minus, and then this turns into a 4ac all over 4a squared. Let's snip this, put this on the next page, like so. Alrighty, so now I can combine like terms on the right side. So let's go ahead and rewrite the left. Combine like terms on the right side. So we're going to have a b squared minus 4ac all over 4a squared. Okay. Alrighty, so now what I'm going to do is I'm going to take the square root of both sides, like so. I'm going to take the square root of both sides. Remember, I'd have the plus or minus there, right? Plus or minus. So the left side just becomes x plus b over 2a. The right side becomes, well, it's going to be, I can split this up into the square root of my numerator, which is b squared minus 4ac, and the square root of my denominator. Okay, and again, so the square root of my denominator will be, let's do this, it's also a plus or minus, forgot about that. The square root of my denominator, okay, if I took square root of 4a squared, okay, well the 4 is a perfect square, which is 2. A squared is a perfect square, which is an a. So it's going to be a 2a. Okay. All right, next what I'm going to do is I'm going to subtract a negative b. I'm going to subtract this from both sides. So I'll have x is equal to a negative b over 2a plus or minus square root of b squared minus 4ac all over 2a. All right. Well, this finally I catch a break here. It looks like we have a common denominator. So the common denominators, all we're going to do now is just combine the numerators, right? So with my common denominator, I now have x is equal to, we have a negative b plus or minus the square root of b squared minus 4ac all over 2a. And that is how we get the quadratic equation from completing the square. And that is why the quadratic equation solves it every time, 100% of the time, if you do it right. Okay. And of course, let's go ahead and put that equation again on the next page. Okay. Again, which is exactly what I got on the previous page. X is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay. Now, here's the thing. I have noticed that when people use the quadratic equation, they'll do this. They just put the radical over 2a. It's all over 2a. Okay. As long as you don't make that mistake, it is 100% of the time just plug and chug. Just plug it in and you're done. Okay, we'll plug it in and do the arithmetic. Okay, so let's do an example. Okay, and let's do this. Maybe I'll color coordinate. I'll go blue, red, yellow. So we'll say 3x squared plus 2x minus 2 is equal to 0. Okay, now bear with me. I'm going to try and color coordinate this quadratic formula. Negative b plus or minus the square root of b squared minus 4 times a, which is blue, times c, which is yellow, and that is all over 2 times a, which is blue. Okay. And that is x is equal to. Okay. Whew. All right, we're going to follow along with that particular, and let's just see here. Let's go ahead and put a nice line down the middle, just kind of demonstrate one side and the other. Okay, so x is equal to negative b. So it's going to be a negative and then 2. Okay, and I 100%, I'm telling you now, this isn't a suggestion, put this in parentheses every time, because you might think you're cute, and if this is a negative 2, you might just be like, negative 2, and then that's, well, heck, that's the same thing, right? And you're gonna mess up. Okay, if it was a -2, you'd say a negative -2. Okay, now again, please, every one of these numbers put in parentheses. Okay, so the negative out front, and then we're going to put the number 2 in parentheses, and it's going to be plus or minus the square root of, and we're going to again put it in parentheses, 2 squared, and then we've got a minus 4 times a, we're going to put in parentheses every time, which is 3, times c, which is a -2, and I probably should have done that. Let's see here, we'll do this, -2, okay, so we've got a -2 all over 2 times a, which is 3. Okay. Now, before I go any further, let's go back to my rule of thumb here. If I was given this particular problem, and I was told to solve this problem, I would first try to factor it in my head, okay, because the easy ones are easy to factor, right? And if I can't factor in my head, I'd jump straight to the quadratic formula. So I'd look at it, and I'd be like, nope, not factoring that in my head, and I'd jump straight to the quadratic formula, which is what we're doing now. Okay, so let's do the arithmetic here now. So I've got the -2 plus or minus. Okay, so I've got 2 squared, which is 4. Excuse me. And then I've got a -4 times a 3 times a -2. Well, -4 times a +3 is a -12. -12 times a -2 is a +24, so it's going to be plus 24. All over 2 times 3, which is 6. So I've got -2 plus or minus the square root of 28 all over 6. Okay. Well, the square root of 28, I can, I know that's a 7 and a, so let's put this over here. I know 28 is 7 times 4, so I can say -2 plus or minus 2 on the square root of 7 over 6. And again, let's recap real fast what I just did. 28 is 7 times 4. So square root of 7 times 4. I take square root of 4 out, which would be 2. So I got 2 on the square root of 7, which is what I have here. Okay, so let's go ahead and actually transplant this particular solution. Let's transplant it over here. Okay. Alrighty, so I've got the reason why is because we can fix this up just a little bit. We can split this into, so we've got x is equal to, now, yeah, I don't think a Pearson will take that as a solution, right? Because we can reduce it, right? So we know we can reduce this into a -2 over 6 plus or minus a 2 over 6. Sorry, 2 on the, let's do that. 2 on the square root of 7 over 6. Okay, well, -2 over 6, so that just turns into a -1/3. And then plus or minus, this turns, that's a 1, this is a 3, so it just becomes the square root of 7 over 3. And then we're done. Okay, so that's it. That's quadratic formula. And I don't know about you guys, but that is so much easier than doing the completing the square. But again, the bad news is you're going to have to complete the square later on in this course. Okay. All right, next up we're going to talk about the discriminant. All right, so the discriminant. And realistically, these rules, okay, you might be thinking, oh, I have to memorize more rules. No, not really, because check this out. Oh, that's not it. All right. So never mind what's behind this, okay? All right, so here we go, the discriminant. The discriminant, given a quadratic equation, ax squared plus bx plus c, the expression d for discriminant is b squared minus 4ac. Okay, well, where did we see b squared minus 4ac? Well, we saw it right here inside of the radical of the quadratic equation. Okay, quadratic formula, sorry. Of the quadratic formula. Okay, so let's just think here. Okay, well if d is again that number. If that number is greater than 0, okay, so if it was like the square root of 7, right, or the previous page was square root of 28. Okay, then what you're going to do is and again there's a plus or minus out front, all that good stuff. Then what happens is we have two solutions, right? My two solutions were -3, -1/3 plus the square root of 7 over 3, and -1/3 minus the square root of 7 over 3. Okay, so I had two solutions, right? Two real solutions. That makes sense. Two real numbers, right? Okay. Well, if that discriminant was a negative number, right? So what if it was -28? Okay. Well, then we would probably still have two solutions, right? Because we'd still have the plus or minus out there, right? But now we'd have two complex solutions. Okay, so let's actually go ahead and erase. Has two real solutions, like we said. And if it was a negative number, if it was less than 0, then it would have two non-real solutions. Okay, because again we'd have the I in there. Okay, well now, but what if the discriminant was 0? Well, if it was 0 in there, well, what is the square root of 0? Well, it's 0. I mean, I could add 0 to anything to infinity, right? I mean, my age is 34 plus 0 plus 0 plus 0 plus 0 plus 0. It means nothing, right? So, if this was like a 3 plus or minus that over 4, right? Well, plus or minus 0, that doesn't really matter. It would just simply be, 3/4, right? So that tells us that we would have one solution. Okay. So again, these aren't, I mean, you can take the time, I guess, to rigorously memorize them, but you're doing yourself a disservice because it's really just that easy, right? Okay, so let's go ahead and do a discriminant problem. I'm pretty sure that's the last one for the day. To current, there it is. Okay, so A. Okay, use the discriminant to determine the number and nature of the solutions to each of the following quadratic equations. So again, let's do A. A, we would have negative B. All right, so D, my discriminant is equal to, it's not negative, I'm sorry, B squared, so it's going to be again, I put these in parentheses, 2 squared minus 4 times A, which is 3, times C, which is 2. Okay, so I do this math. Well, 2 squared is 4 minus, okay, so -4 times a positive 3 is -12. Sorry, -12. And then -12 times 2 is -24. So it would be -24. So I have a -20. Hang on a second. All right, so I hope my mic is actually muting. But anyways, so I've got a negative number. All right, so this tells me it's this one right here. So this tells me that A is going to have two non-real solutions. Okay, so let's write that as a so 2 non-real. It looks like normal, doesn't it? Oh well. Two non-real solutions. Okay, and then let's do B. Again, the discriminant is going to be equal to. We're going to do a little bit of rearranging here, so let's go ahead and rearrange. Okay, so I'd say 4x squared minus 4x plus 1 is equal to 0. Okay, alrighty. So my discriminant is, again, b squared. So my b here is a -4. Okay, so I would say, again, I'm putting it in parentheses, -4 squared minus 4 times a, which is 4, times c, which is a 1. Okay, so -4 squared is 16. -4 times a positive 4 is a -16 times 1, so -16. Square equal to 0. So that is this one. So we're going to have one real solution. Okay, so we will say one real solution. All right, and that's the discriminant. Pretty easy stuff. And that does conclude. Okay, I got a message. One moment. what happened to the x. We're not concerned with the x right now. We're only concerned with again this formula here, the discriminant formula, is just simply b squared minus 4ac. We're not solving for x at all. Okay, we're just trying to find the discriminant. We're trying to figure out, are we going to have two real solutions, two non-real solutions, or one real solution? That's all we're doing, is figuring out that. Okay. Alrighty. Anyways, if no other questions, I'm going to conclude today's lecture there. I'll give you about 10, 15 seconds. Alrighty.